So we want to learn how to calculate average atomic mass. Now, when you look at a periodic table and you look at the information that is provided there about the various elements, you're going to see something like this. Maybe something a little similar, maybe a little different. There may be a little more information. Now, the top number for carbon is its atomic number. That's usually the whole number. And then there's a decimal, or a number with a decimal, that really is the average atomic mass, and we want to learn how to calculate that number. Now, in order to do this, you have to be concerned about the various isotopes' relative abundance, or excuse me, percent abundance, not relative abundance. And if you look at this graph, this guy's got 4 relative abundances, 4 isotopes with different percent abundances. The first one is and it's got a percent abundance of about 60%. The second one has got a percent abundance of 25, and then 15 and 5%. Now, you can see the percent abundance doesn't really depend upon the mass. It could vary. It's not going to be linear or necessarily. It could be, or it doesn't really matter. Or not that doesn't matter. It kind of depends upon the isotope itself. Yeah, the answer, what you do is you'd multiply the percent abundance as a decimal times each individual mass, and then you'd add them up. All right? Now, there's my information or graph on the left. Another way that you think about this, or a simpler way to write the formula, is the mass times the percent added by the mass of the second isotope, mass multiplied by its percent. And you just need to remember that whatever percent abundance that you're multiplying it as a decimal, not as an actual percent. So first isotope's mass was 60%. Its mass was 10, so it's 0.6 times 6, then 0.25 times 11, 0.15 times 12, and 0.05 times 8. Then what you would do with each of these different little factors is you'd multiply them and individually, and you're going to get 4 different products. And then the next thing is to add them all up. So 6 plus 2.75 plus 1.8 plus 0.4, and that equals 10.5. And the last thing to do would be to round. And in this case, we're going to get 11. Now, let's go through another example. Let's say calculate. It says I've got magnesium, and it's got these isotopes. Here are their masses, and here are their isotopic abundance. So here their atomic mass, and that's really close to the mass number over here. But when you do the math, you would use this, and here are my isotopic abundances. All right. And to do this, I'm going to do the same thing as I did on the last one. I'm going to take my percent abundances, and this is called isotopic abundance in this problem, and I'm going to make them decimals and then multiply them by their individual masses. So I have 3 little mini multiplication problems, and that gives me this 3 different factors, or 3 different products. And then I would add them all up, and the last thing I do is go by round for sig figs, and all my percentages have 4 sig figs, so my answer can have 4 sig figs. So my answer becomes 24.3 grams is my answer.